All right, today let's take a look at the mean value theorem. And the mean value theorem, I'm going to call it the MVT, says that if a function is both continuous and differentiable, it has to be both, on the closed interval a to b, okay, and I meant to say there if it's continuous on the closed interval and differentiable on the open interval. All right, so it needs to be continuous on the closed interval and differentiable on the open interval. Then there is this point C, and such that, and this is what you're going to want to remember, f prime of C is equal to what we recognize as our average rate of change, f of b minus f of a all over b minus a. This thing right here, we should recognize this as the average rate of change. Rate of change. Or our slope of a secant line. So what we have going on here is we've got this function, all right, and here's A, and here's B, here's our 2 points. If I connect these 2 points like that, I have this secant line, and that's what this slope tells me, the slope of that secant line. Well, what the mean value theorem says is that if this function is continuous and differentiable, then there is one place in between, and you can see it on this graph that I drew, right here. There is one value C where the slope of the tangent line to the function, and remember that's what f prime of C means. It means the slope of the tangent line, to where the slope of the tangent line is the same, the slope of the tangent line is the same as the slope of the secant line. All right? You need to understand this progression, especially for the AP world. All right? We start off thinking f of x is differentiable. If it's differentiable, then it's continuous. If it's continuous, then the mean value theorem applies. All right? So let's take a look at this problem here, or this next slide. A function that is well behaved on an interval has the property that the instantaneous rate of change, all right, that's this, of the function somewhere in their interval is equal to its average rate of change, and that's this. And that's what I just illustrated up here. All right, some place in this interval, the slope of the tangent line is the same as the slope of the secant line. All right. Now let's take a look at this free response question from 2011. The continuous function f is defined on the interval -4 to 3. The graph of f consists of 2 quarter circles and 1 line segment as shown in the figure. Find the average rate of change on the interval from -4 to 3. There is no point C from -4 to 3 for which f prime of C is equal to that average rate of change. Explain why this statement does not contradict the mean value theorem. All right. Well, the average rate of change is going to be f of 3 minus f of -4 all over 3 minus -4. All right. And so f of 3 is, according to our graph here, negative 3, minus f of negative 4, which is negative 1, all over 7. So this is negative 2/7. So we have found the average rate of change. Okay, we got that done. But they're telling us that there is no point C from negative 4 to 3 for which f prime of C is equal to that average rate of change. Explain why this statement does not contradict the mean value theorem. Well, it's because this thing is not differentiable everywhere. Okay, we have this situation right here on this graph where we can see that the function would not be differentiable there. All right, so this thing does not meet the conditions of the mean value theorem because it's not differentiable because of this thing here. Okay, we can definitely tell that our left hand and our right hand derivatives are much different. All right. So when the hypothesis of a theorem is true, the conclusion must also be true. When the hypothesis is false, the conclusion could be either true or false. And here's your most important statement. The mean value theorem is tested regularly on the AP exam, particularly in problems with functions presented graphically and or with a table of values. Let's look at this problem from the 2008 exam. The function f is continuous on this closed interval from negative 2 to 2. And f of negative 2 equals f of 2 equals 0. If there is no c where f prime of c equals 0, which of the following statements must be true? I want you to notice right away there is no statement about differentiability. Okay, there's no statement, all right? And so that leads us to letter E. For some k, the function, if there is no c, all right, where negative 2, where c is sandwiched between negative 2 to 2, which of the following statements must be true? Well, it's that for some k, f prime of k does not exist. And we know that because there's no statement about differentiability. If there's no statement about differentiability, the mean value theorem does not apply. So that f prime, we called it c, they called it k, f prime of c does not exist. Let's look at another problem. The function f is continuous and differentiable on the closed interval 0 to 4. The table above gives selected values of f on this interval. Which of the following statements must be true? Well, we could do our average rate of change. All right, we could do f of 4 minus f of 0 all over 4 minus 0. And we would wind up with 2 minus 2 over 4, which is 0. All right? But the problem, which of the following statements must be true? Well, there's not enough information for this one, this one, this one, or this one. Okay? The only thing we know is this one right here. Because they did tell me that it was both continuous and differentiable. So the mean value theorem applies. All right? And what we did over here was we found the average rate of change, which means that there has to be, according to our definition of mean value theorem, there has to be a place where the slope of the tangent line is the same as the slope of the secant line. Let's take a look at this next problem. The height of a tree, this is from the 2018 exam. The height of a tree at time t is given by a twice differentiable, that's important, h, where h is measured in meters and t is measured in years. Selected values are given in the table above. Explain, see that word explain, that's important, all right? why there must be at least one time t from 2 to 10 where h prime of t equals 2. All right? Well, if we look at this time slot from 3 to 5, if I do f of 5 minus f of 3 all over 5 minus 3, I get 6 minus 2 over 5 minus 3. That's 4 over 2, and that's equal to 2. So there is the right side. Remember what the mean value theorem says. It says that there must be an f prime of c such that f of b minus f of a all over b minus a is the same thing as f prime of c. So we've done the right side of this. This is saying to explain why there must be true. Well, we've got the information that we need. When they say explain, they want you to make a statement. So we could say, because h of t is differentiable, it is also continuous. So the mean value theorem applies. There's our explanation, okay? We need both this, we need this piece right here, and we need this piece right here to explain why the mean value theorem applies. We've done the right side over here. We did our average rate of change over here. And on the left side, we justified it by going through the definition of the mean value theorem. And we will stop there for today.